guess we'll start by asking you, how is the SourcePoint 8 different to the SourcePoint 10?
SourcePoint 8 is an 8-inch, the SourcePoint 10 is a 10-inch. And that sounds glib, but the reality is almost that. Having developed the SourcePoint 10, and then wanting to develop a smaller one, mainly for the reason that people come in having seen all the pictures and see the SourcePoint 10 and go, oh, that's bigger than I thought it was. And the sarcastic answer wants to be, how big do you think a 10-inch driver is and the box it would go in? We did it for a reason, for a performance reason. It allows us to get better sensitivity, better bass extension, and of course the bigger driver, just more drive. But we recognise that that doesn't meet everyone's requirements. No matter how much you like the sound of it, it might be just too big visually in your room, or it might load the room too much, if you've got a small room. So we'd always had this intention of doing a smaller one. But the difficulty when you do that, no matter what the design is, how do you keep the sound consistency as you're changing driver sizes and maybe engineering new cones? You want to keep the same character, but you give up on something, sound level, bass extension. So when I was examining what are the characteristics that I need out of an 8-inch driver to get the right alignment for the bass in a smaller cabinet and with a smaller cone area, and first thing I realized was the motor strength, the BL product. It's the same. It just happens that the smaller cone in a smaller box requires that same BL product that the big one has. So that means the whole motor structure can stay the same, which means as long as you keep the same voice coil size, the tweeter fits. So basically take everything that's connected to the chassis of the 10-inch and put it onto an 8-inch chassis. So now what do I do with the cone? And you could say the primary character in the midband that determines how the cone behaves, it's all down closer to the voice coil. The edge of those frequencies starts to decouple. And we know when we're making cones, we'll stamp them out, or whatever process is used to make them, but there'll be the outside area, and you use a trim tool to just trim off the edge to the diameter that you require to glue to the surround. So what if I just adjust the trim tool, basically, and take a bit more off the edge? We reduce area, but we keep the same character. So I can literally take the cone that I've already made for the 10-inch and just trim it a little more. It becomes the 8-inch. And all I have to do is engineer a new surround that bridges the gap between the edge of the cone and the new 8-inch chassis. So in a way, I didn't have to do any work. And again, a glib answer, but that's the basic concept, that the 8-inch is the 10-inch, but it's an 8-inch. And then every other dimension, the first attempt was, okay, so it's 10 goes down to 8, so it's 0.8 times. So let's just adjust all the CAD drawings and every dimension reduced to 80% and see what it looks like. So it scales pretty much exactly, both in terms of overall linear dimensions, thicknesses of the baffle and the box wall thickness, internal bracing. And when you look at the resultant drawing, or you look at a photograph, you're hard pushed to know which one you're looking at when you've got nothing to judge scale by. If you look carefully, you see that, well, the logo is the same size on both, so proportionally it looks a bit bigger on the 8-inch, as does the tweeter. But you have to look carefully to realize that. So it really is just a simple scaling of the 10-inch, and yet the driver really is, like I say, really is the 10-inch. And now it's a matter of then, because we can't have as high sensitivity, as soon as you reduce box size, your trade-off between efficiency, box size, sensitivity determines that I can't have the same sensitivity level or the same bass, or you mix a bit of two, you reduce a bit of sensitivity, you reduce a bit of the bass extension to give you that, but that needs a redesign of the crossover. So now the job of voicing the speaker becomes re-engineering the crossover to keep the same overall sound balance. You drop the level of the tweeter, change the roll-off in the crossover. So I'm measuring and listening to try and get that same voicing of the speaker. You always voice a speaker. You've always got a target for your measurements and a target for what it sounds like. And so that's the remaining challenge when you're trying to engineer the sound of the 8-inch versus the 10.
Can you measure it all the way, or do you have to, like measurements might take it? This is what I hear from other engineers. Measurements will take us 90% of the way, and maybe the last 10% has to be done with listening. Is that the same with you?
To the horror once of the president of one of the companies I worked with, I actually launched the prototype of a speaker. I was going to take it to the show, not having listened to it until I got to the show, because I was confident in all the measurements I'd made. And it was required that he was given the chance to listen to it. And he goes, "Oh, that sounds pretty good." I'm going, "Yeah, I know." Shouldn't admit that on camera, of course. So, yes, a lot of it is measurement. But what I always say to people, there might be some target curves that you're supposed to aim for. But first of all, those were established by listener preferences. It's not like that target was the one that gave the closest approach to the original sound. It just didn't, because you weren't, the records, the recordings you were using to judge the sound of the speaker, commercial recordings. Who knows what was done processing-wise during that recording process? You pick any record in your collection. Do you know what microphones were used on each of the instruments? Do you know what filtering EQ was used on the voice versus the guitar to present them correctly in the mix? Really is an unknown. So to say I can listen to the record and know what it's supposed to sound like, it's not there. And that would presume that in the recording process, you had a single vision of what that mix should sound like. You pick your studio monitors, and as long as it sounds right on that monitor, in that location, in that mixing room, that's what I'm aiming for. It doesn't work like that. That mix has got to work for listeners who are listening in lots of different ways and present the essence of that music. So in reality, once I still have target responses, and it's a mix between what it's doing on axis and what's it doing off axis. And that's helped a lot by going to concentric drivers, because their off axis performance in all directions is a lot more consistent with what the on axis response is than when you got drivers that are separated with different directivity responses. And so now you're balancing how critical is the response at 30 degrees or the sum of the sidewall reflections, these kind of issues. It's just easier with a concentric driver in that regard. But I'm still dealing, I always say I'm dealing with imperfection. Doesn't matter what price point the speaker is, we're still having to deal with an imperfect performance.
Is it generally agreed that a loudspeaker's off-axis response should follow its on-axis response as close as possible to sound the best, in air quotes, as possible?
So in regard to what those off-axis curves or sounds should be, you've got different ideals, let's say. Let's take the concept of an omnidirectional speaker. Now there you have no decision to make. It's omnidirectional means it's the same in all directions. You could decide whether that's an optimum choice for a loudspeaker in a room, and some people will say, yes, that's what I want. Others will say, no, that's not what I want. If you step back from it being omnidirectional, you could say, I want it directional, but what does that mean? Does directional mean it has exactly the same frequency response shape, but just dropping in level as I move off that axis? That could be viewed as the ideal performance. Is it acoustically practical? And you go, with most loudspeaker designs, no. And there's speakers on the market that are attempting to get closer to that, to maintain a directivity down to a lower frequency. Speakers that have maybe a cardioid characteristic at low frequencies. You see some designs moving in that direction. So, but there's still going to be, in general, a falling off towards the high frequencies as you move further off axis. And so the goal would be, yes, it's gently falling, but it still maintains as smooth a response as possible. But there'll be a break point where it doesn't really change much up to a certain frequency, and then it'll taper off. But ideally that taper off should just gently fall off. If there's any character to that shape, that'll impart character to the sound and to its interaction with the room, because the room is feeding that energy back to you. We're not listening at anechoic chambers. And so the off-axis performance does become important, and the tonality of that off-axis performance becomes important. If the tonality of the off-axis is different from the tonality of the on-axis, beyond just a simple gradual reduction as you go up in frequency, now you have a balancing act in the room. Because what proportion in any particular room are you hearing between the direct, the on-axis sound, and the off-axis sound? And this is why the worse that match between those two parameters, the more difficult it is to place the speaker in a room, because the ear's processing that sound and trying to say, I think the speaker sounds like this, but when I move it in the room, that room contribution is changing, so it really sounds like the other. And in that respect, therefore, you could say the directivity performance of the speaker is a critical factor in the design. And there's different ways you can start to engineer a better, more consistent directional characteristic. And for me, that has always been do a concentric driver. It certainly makes life easier. There might be other compromises you have to make, and since everything is a compromise, it's how you balance those compromises determines what that particular speaker sounds like, or in fact what any design from that particular engineer would sound like.
Why do we want an off-axis signal generation when all that's potentially going to do is generate side reflections in the room?
Because you can't avoid it. One of the things, let's take an amplifier, for instance. It's got an input and a single output. A speaker has got an input and an infinite number of outputs, because it's a three-dimensional waveform generator. The sound is going in every direction. You physically cannot make a laser beam. Okay, there's a small qualification. That in engineering, there's always qualified statements. You can't make a laser beam sound that just goes to the listener. The qualification is if you use ultrasonics and you demodulate them at the ear, there's technologies where you can be walking around and someone can target that only you hears the sound from that speaker, and they can target and follow you around, which is weird. But in general, what we're doing with regular loudspeakers, it's going to have an off-axis performance, and it's going to be very difficult to make that exactly the same as the direct on-axis sound. So we have to deal with that. We have to deal that we're listening in a room. Because you could say, if I was listening in an anechoic chamber, who cares about what it's doing off-axis? Because I only literally hear the on-axis sound. If it's pointing at me, that's the sound I hear. But anyone who's tried setting up a stereo system in an anechoic chamber and listening to it, it sounds awful. You know, beyond the physical feeling that you get if you sit in an anechoic chamber for any extended period of time, it's weird. I'm used to it because I've done it a lot. But when you try and listen to music that way, it just doesn't sound right. And therefore, we want to have some room interaction. It just feels better to us when we listen to music in a room. But then we've added the problem that what is the room doing? So you've combined what is it doing off-axis to how is that room returning that off-axis to you? How long is it lasting? If you've got a highly reverberant room, you've almost set a sort of resolution limit to the sound that you're hearing, because while the new sound comes to you first, the old sound is still banging around the room and setting a lower limit because of it. That new sound is now being masked partly by what's reverberating around in the room. And that reverberation is a coloured, spectrally coloured sound. So we have a lot to deal with when we're designing that speaker. You know, it's not just measure the response in one direction and try and flatten it. For example, the ideas of doing an inverse transform of the impulse response and measure the response on that axis, do an inverse, and now we've got basically a straight line response. Well, that's not enough because it's not taking account of all the off-axis sounds. If it was a perfect directive to the response of whatever type you'd chosen, and it was an exact match for the on-axis, but you know, just dropped in level or maybe tilted down, you might begin to say, if I perfectly correct the on-axis, that can kind of work, but it's rarely that straightforward. So it means not only are we balancing just how good we can make the drivers in an absolute sense, but what it's going to do when you put it into the room. And so an important part of being a speaker designer is sort of being a room designer, because you know the speaker's going to go in a room, and then maybe you're second guessing what rooms it might go in, where people may be restricted from a room placement. The secret of doing shows is finding that magic spot and taping it there and going, okay, it's taken me hours to find that spot. Hopefully I've put some kind of room treatment into the room to help to realize a particular sound in that room that you go, okay, this represents what I want the sound of my system to represent. Now, the difference when you're working at a show is you've got a day to do that. At least when you're in the home or in your own listening room in your lab or whatever, you've got a lot of time available to optimize that. But that's why I often look at pictures that people post online in forums of the systems in their home. And I'm not looking at what equipment they've got. I'm looking at, well, where are the speakers? And of what I can see in the room, has anything been done to try and help tame the room? And you have to recognize the fact that a lot of the time, nothing's been done. And it's either due to ignorance in not understanding just how important the room is. But it's also, yeah, I know the room's important, but come on, I'm not gonna put these big squares stuck on the wall, no matter how much it might help. I just don't have that freedom to do it. And then room placement. A lot of rooms are so asymmetrical with doorways that you can't put the speaker over there because it blocks entrance into the room. And so you squeeze it and one's under the stairs and one's stuck in a corner. And sometimes I look and go, why are you even spending money on this system? Because you've hampered yourself so much with the room. And I know we can maybe learn to process out some of the character of that over time and then assess what the equipment itself is doing. But you'll still never reach that full level of sound quality, the potential that that system can have if you haven't taken care of the room. And I'm always, my goal in any presentation, to the extent that I have the capability in any one setup, is to show what is possible with that system. That if you do this, this is the sound potential that my speaker or the partnering equipment with my speaker can create. If you don't get that, at least you knew it was or is possible to reach that level. And I accept that you're not always able to get there, but at least you've heard the full potential.
Can I ask you about waveguides? Mm-hmm. Because with your coaxial design here, the tweeter sits in the middle of the mid-bass driver. So the mid-bass driver is acting as a waveguide.
Yeah.
But it's moving. So the waveguide that's meant to be directing or affecting the dispersion of the tweeter, it's moving all the time. Is that a significant negative impact on the tweeter's output or not?
For the people who don't believe in concentric drivers, it's a significant factor. To the people who do, we'd say, no, there's ways you can ameliorate that. Since I first started to hear concentric driver type technologies, and when I was working at KEF, for instance, and of course the KEF Uniq isn't the first concept of a concentric driver. You've got the tannoy type designs, and they're all trying to do the same thing, get more of a point source location for the sound, because as soon as you separate the drivers, you've got time delay effects. They can only be time aligned in one direction. As soon as you change the direction, they're not any longer time aligned. And that's if you believe in an overriding important factor in design is time aligning. And I don't need to go into do I believe that or not, but nonetheless, if you want time alignment, you can't get it in all directions once you separate the drivers. But that means, like I say, putting the tweeter down the middle of a waveguide. And so the first question is, what is a waveguide? And people say it's kind of a horn. Well, yes, technically a horn is a subset of a waveguide. A waveguide means any means you have of controlling how the sound spreads as it emanates away from a sound source. And putting it flat on a baffle, that's a waveguide because it's stopping it moving backwards above a certain frequency. Below a certain frequency, once the wavelength becomes large compared to the dimensions of the radiator, it will always radiate omnidirectionally, and then it will always concentrate the energy forward above a certain frequency. And the shape of that baffle determines where that transition is frequency-wise and how it transitions from one to the other. So a waveguide is a means of controlling that transition. And a horn is an extreme example of that. The reason a horn is efficient is basically it's throwing all the energy forward. And so it sounds louder in that particular direction. A waveguide does the same thing, but we might not be aiming at extreme efficiency. We're aiming at a particular kind of waveguiding action to give us that transition slope, which we talked about for off-axis sound. So you can have a waveguide, and obviously you have a waveguide when you've got a separate tweeter from the woofer. And I've done plenty of designs like that, and I've been doing waveguides since the late 80s, early 90s. Because even with separated sources, you want them to have matched directivities so that as you transition through the crossover point from one driver to another, that it not only transitions smoothly on axis, but it also transitions smoothly off axis. If you're crossing over from something, a bass driver with a large diameter, which is now quite directional at the crossover point, to a small tweeter, which is not directional at all at that point, if you match them in one direction, they cannot be matched in the other. So the waveguide gives you that capability of matching the directivities through that crossover region. And of course, that's a fixed waveguide. Now you take that tweeter and you put it in the middle of a bass driver, and if you think of the shape of a cone, it's similar to the shape of a waveguide. So you're already starting to think, oh, it's controlling the directivity once you do that. Now you've got a dual purpose for the shape of the cone. Ideally, you give it a shape that is exactly the same as an optimized waveguide would be for that particular tweeter. And that means the shape of the cone, the shape of the surround are all smooth, continuous functions that blend out onto the baffle, and now I have optimum directivity control. But there's a caveat, that is that shape of cone the right shape of cone for it to perform mechanically as a good mid-range cone performance? So you've given yourself added difficulty in one respect in the design. The other fact is a cone has to move to produce sound. And so now you've got the fact that it is moving. How do you allow it to move? You need a surround, and we typically use a half-roll surround. Well, you would never stick that kind of disruption onto a waveguide, because as the sound gets to the edge, reflects off that bump, causes interference. You've lost that smoothness of contour. So now maybe I have to engineer a totally different kind of sound, surround that works best for both a waveguide and as a termination for the cone and allows it to move. Now let's look at what is the impact beyond those factors of the walls of your waveguide moving back and forth. And the first thing everyone thinks of is Doppler distortion. You know, Doppler distortion, train comes towards you, the sound pitch goes up, it moves away from you, the sound pitch goes down. Since that's defining the boundary of the radiation, won't I get Doppler distortion? And technically, there are ways that you could measure the Doppler, but audibly, Doppler is the very least thing we hear when that waveguide starts moving. We're just not sensitive in reality to Doppler distortion. What we are sensitive to is amplitude modulation effects. So we think about the transition from the tweeter to the cone. When the cone is at rest position, it's perfectly aligned to give us the waveguide characteristic that we want. But imagine now the cone moves forward, then the tweeter now relatively is behind the surface of that waveguide, and it's in a little tube, which is the voice coil former. So it has to get through that tube before it starts to travel up the cone. That gives it a different frequency response. Now imagine the cone's going the other way, it's moving backwards. Now the tweeter is protruding forward of the waveguide, so you again got a mismatch, which gives you a different frequency response. So changing frequency response as a result of the bass moving the cone gives you amplitude modulation. And we hear that. So the design of a concentric driver, and it's in a certain frequency range, but it's readily measurable. Then the question is how audible it is. And definitely if you take things too far, it becomes audible. And then the question is balancing the audibility of that mechanism versus what you might believe is the improvement from solving all these other directivity issues. Which one's more critical? And different engineers obviously will have different answers to that. How do you minimize that? Well, you obviously minimize the amount of movement, clearly. What's an obvious way of minimizing the amount of movement? Minimize the amount of bass that that cone is trying to produce, because bass requires more excursion. So a three-way is an obvious example. And I've said over and over again that I would never do a two-way concentric. I would always do a three-way. But when I was starting this project, you think, well, the other way of minimizing displacement is to have a bigger cone area, because bass level is the product of cone area times cone displacement. And so if you go up in area, for any given bass sound pressure level, you need less movement. 10-inch produces bass with very little movement in comparison to a 4-inch or 4.5-inch concentric driver. Therefore, I can get much less modulation. And so that was the choice I made in this. And it allows me, a three-way system is clearly more complex, more difficult to design, more costly, because you're now a whole extra bass driver, the crossover, a passive crossover, crossing over, let's say, anywhere between 100 and 200 hertz, requires large components, which are expensive. It can give you impedance problems. There's a whole different set of things come into play when you're designing for a three-way. And if I can do it as a two-way in this particular example, I can take that cost and put it into the engineering of the driver. And there's a whole host of other modulation effects, distortion effects that occur in the motor structure of a driver that traditionally we kind of don't really do too much about. We might put some copper in the gap to help reduce some of them, but the basic structure of the motor is pretty common amongst all drivers. There's a move of late to try and fix all of that, and there's some manufacturers are doing a really good job of examining what those non-linearities are and how to minimize them. It's not that we didn't know this is happening, it's how much importance are we paying to them. And as we reduce every aspect of getting better and better designs from speakers and exploring different materials, we start to look at all these other aspects and can we improve them. So if I've got money to play with, I can make the driver better, or I can make the cabinet better. So that's what I started to do when I was working on the SourcePoint 10. And when it comes to SourcePoint 8, okay, so I was never going to do a two-way, but since it's big, I can do a two-way. Well, the 8 is smaller, so isn't that the slippery slope of going back down? But you also have to look. I said there's this amplitude modulation distortion. Is that what I'm hearing as a limit to how good a concentric driver could be? Or is it these other modulation effects that the reality is that's what I'm hearing? So that's where I'm looking. I'm looking at all the sources of nonlinearity and saying, what can I do about these? And that's where my brain is right now in the development of the drivers I'm working on, reducing all these other modulation effects that create not just harmonic distortion, but intermodulation distortion. How does the speaker perform as it's playing louder and louder? I want to try and get this sound where there seems to be, the limit is your ears, not the speaker getting into difficulty and making it, oh, I can't listen to it that loud. Is it because you can't listen to it that loud, or the speaker can't play comfortably that loud?
Does that therefore mean, if I'm understanding you correctly, that basically every speaker ever designed, ever produced, is a compromise, and the designer has to just pick which battles he or she wants to tackle in producing to a certain price point?
Oh, totally, yes. And that is a very personal decision. you're working with imperfection. And I've said this over and over again. My job is to balance those imperfections. So if we believe there's an optimum response shape or directivity pattern to aim for that says, if it measures like this, then it will be the perfect speaker. And we can judge a speaker simply by looking at that. But we're not dealing with perfection. We're dealing with imperfections. Even if we have a target to aim for, we're not going to get there. We're going to approximate to it. And whether it's your belief in time alignment, tonality, directional characteristics, you're only approaching perfection, you're not getting it. So now as a designer, your job is to balance imperfections. And that is a very personal decision in my view, which you've only got to hear the variety of different types of loudspeaker sound to understand that different designers have aimed for different ideas and different listeners have accepted different ideas. And so given that, what am I aiming for? Which things can I accept in a design? Which things are just no, 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 like, oh no, I'll never do that because it doesn't sound like I want it to sound like. And what does it mean when I say it has to sound how I like it to sound? And how do I judge that? What music do I listen to make that judgment? And not just in terms of what style of music. You know, am I a headbanger? Or am I a small-scale jazz type listener? And so what are the characteristics in the music they have to bring out if it's determined by the style of the music? And of course, you know, in the old days, the belief was you have your rock speaker and you have your classical music speaker. That shouldn't be. The speaker should be independent of the type of music, because there's still characteristics in all kinds of music that need reproducing correctly. But maybe some types of music have got a higher energy concentration in certain frequency ranges at much higher levels that it's important to be in control of, that might not be as much of an issue with other types of music. But still, largely designing so that it's not the music that determines how you design the speaker. But it's still me making those decisions about what I can accept and what I can't. And then the question becomes, how do I judge that? I have to judge the sound of the speaker by listening to the sound of the music. What does that music, what's it supposed to sound like? How would I know in any particular recording that's one of my favorite pieces what it was supposed to sound like? Or is it just fiddle till it makes me happy? You know, is it an emotional decision? Am I taking technicality out of it at that point and going, you know, when I've done this to the speaker, that piece of music makes me cry. Whereas until I get to that point, I'm listening to it and judging, as opposed to just sitting back and going, yeah, that's it.
So is true to source, the expression true to source, a bit of a nonsense?
If you don't know the source, it has to be nonsense. Now, you could argue that if you're in control of every stage of the recording process, you were there at the original event, you chose the microphones, you chose the recording process and the mixing, whatever was required to create the sound at that instant, that now you know and you remember exactly what it was like then, and you can subsequently always adjust to that impression of what you had. You could begin to say there's a truth to the source. But the reality is, if the source is the musical event, rather than what was coming through the microphones, then the placement of the microphones, the choice of the microphones, immediately alters the truth of that statement that the music sounded like that. And that's assuming we're talking about music that exists in a space, that you could listen to it without electronics in the way. You know, a chamber orchestra or a full orchestra in a hall. But a lot of the music we listen to never existed in that form. But I could say that, well, if I design a speaker, and in the process of designing a speaker, I only made judgments on music that could have existed independently of the capturing of that. And then that has to translate that once I've designed the speaker to satisfy that criteria, it should sound right for everything. But in reality, we have so few opportunities to do that part of it. Even if we do, the way we with ears and brains perceive that sound when we're there in the real space that those instruments occupy, we'll never get that effect playing, forget the microphones, playing through two speakers that give an illusion of instruments placed between them. That's a pure auditory illusion. When we hear the vocalist dead center, there's not actually a sound coming from dead center. It's a sound coming at two ears with certain sound altering due to the head and the pinna, and the processing our brain gives us to believe there's something there in front of us. So that's not going to be exactly the same as if we were there listening to it and the cello is literally in front of us there. So we've immediately altered the ability to perceive that original event as it occurred. And maybe I'm pushing that too far as a point to say that there's a limit to how much you can think that we are able to judge any particular recording that we hear and say this represents the truth of the original performance. So once we step away from that, it comes down to, it's not the truth, it's the preference of that particular recording. Right. We like that music, and we like the sound of that music when we've heard it. And there might be other recordings of that particular event that we prefer how it was recorded for that particular event. Was it a pair of microphones? If we had the opportunity, was it a cross pair of microphones out in the hall and we recorded it that way, compared to close mics, mixed? Some people prefer the immediateness of the sound of close miking. Some prefer the hearing more of that acoustic space at a distance away from the instruments. And you've only got to go on anyone who goes on forums and starts following all these arguments, you can spend a lot of your life in wasted pursuit there. But you drop in and look at, I was on a website for a company that sells pro audio gear. And I happened upon this thread about someone asking, what's the best way to mic a string bass? Well, that was a lot of pages of differing opinions of which microphones to use, how many of them, where to place them. You got to have one just by the F-hole. Oh no, you need to place it inside the F-hole. Who has ever heard a string bass by putting their ear right up to the F-hole? But all these different ways of capturing the instrument. Do I know in any particular recording how they did it? No. So if I'm judging it by typical commercially available recordings, I cannot judge the accuracy of that. I can only judge what I like. And if I'm using that to determine what the speaker sounds like, then I'm even further away, and I'm just saying, based on my experience of listening to lots of my different designs, lots of other designs, in lots of different rooms around the world, I have settled on some belief system of this is what I think I want at any particular moment when I listen to it. That's all I can really do. I back it up with as much measurement as I can. One of my most important things in my career of speakers is measuring speakers more accurately and understanding where the inaccuracies in measurement come from. You know, we're talking about, even if we have a goal of a measured performance that we'd like to achieve, we at least need to know we're measuring it correctly. And yet, the vast majority of measurements I see published of speakers, I can clearly see all the inaccuracies that are present in that measurement process. So how can you possibly then relate measurement to what you're hearing if the measurement isn't accurate to begin with? So that further muddies the pool of how you think about all of this. So I've said it before, it's about me in that sense. I determine, having measured with what I would say as accurate measurements, what I want it to both measure like, and when I listen with the recordings I enjoy as a reference point, what that sounds like, and when I'm happy, I'm done. Hopefully you're happy. If enough people are happy, I have a business. If they're not, I have a hobby. I'm only pleasing myself. And that, you know, DIY people can have that satisfaction that you don't have to care about what anyone else thinks. You only care about what you think about the sound of what you created. And
I mean, we're at Munich High End here, right? So this is a display of some of the world's best loudspeakers from a vast array of engineers, loudspeaker engineers like you. And yet all of these speakers
still sound different. Yes.
Right? So is it the case that basically every loudspeaker engineer is trying to give us what he thinks is the optimal version of the truth?
Oh, I believe that absolutely.
Right.
You know, this concept of the more capable and the more expensive a speaker gets, they should all converge to one common sound. Well, clearly in practice they don't. You can take any $200,000 speaker on the market and they all sound different. So it has to come down to it's that engineer who's determined what their preferences are, what they're trying to optimize, and what balance they've placed between all the competing issues that exist in designing a speaker.
Andrew Jones, thank you very much.
My pleasure.